Hello learners of Elimu Live. I'm teacher Kithinji of ACK St. Michael Model Schools, Ongata Rongai. Today I'll be tackling mathematics grade 8 and I'll be dealing with whole numbers. My topic is whole numbers. Under whole numbers, we are going to look at converting recurring decimals into fractions. Recurring decimals into fractions. We have two types of decimals. We have one, what we call terminating decimals. Number two, we have non-terminating decimals. Non-terminating decimals, or what we call recurring decimals, in other words. We have terminating decimals and non-terminating decimals. We have, or we call them recurring decimals. Now, when we talk about terminating decimals, examples of terminating decimals include decimals like 0.5, 0.6, 1.7, 3.4, any decimal that has an end. For example, if you divide half, if you take a number like half and convert half to a decimal, this means it is 2 divided by 1, and which is not possible. So you add 1 here, and then 10 divided by 2 will be 5. Therefore, half as a decimal is 0.5, and this is an example of a terminating decimal. When we talk about non-terminating decimals, we have a number like a third converted into a decimal. Normally, when we are converting fractions into decimals, we use a simple formula that is denominator out, and the numerator in. The denominator out, the numerator in. Therefore, 1 is not divisible by 3, so it's not possible to divide 1 by 3. And when you put a decimal point, you add 0 to 1, which makes it 10. So 10 divided by 3, 3 will get into 10 3 times. 3 times 3 is 9. When you subtract, you get 1. And then 1 is not divisible by 3, so you add 0. Again, these will be 3 because of 9. When you subtract, you get 1. Again, we add 0, sorry. Then 3 times 3 is 9. When you subtract, you get 1. These will continue like that indefinitely, making it what you are calling a non-terminating decimal, or what you are calling a recurring decimal. Now, when you have this kind of a recurring decimal, so our answer here is 0.3333, so on and so forth. This one is normally written as 0.3. When it is written like that, it means 3 is the number that is repeating itself, that is not ending. Now, our topic today is not to get recurring decimals, but how can we convert these recurring decimals into fractions? How can we convert these recurring decimals into fractions? So, that is what you are going to do, converting recurring decimals into fractions. have a screen. I have no screen. Yes, I'm hearing you, but I don't have a screen. I don't have a screen. I have no content. Okay, carrying decimals into fractions. So we have 0.5, where 5 is recurring. This is the first example that we have here. So we want to convert 0.5 into a fraction. So the first step is step number 1. Step 1, if you're told to convert 0.5 into a fraction, step number 1 is to write it in the long form, like we had 1/3 converted into a fraction. We said is 3 divided by 1, which is 0.33333, where 3 is recurring. So the first step is to write it in this form. Bear in mind that the number with the dotted point here is the one that is recurring. So this can be written as, let's call it x. X can be written as 0.5555, going on like that. So when we want now to convert this into a fraction, we shall look for a number or a multiple of 10 that when we multiply by these x, we shall be able to move a decimal towards the tenths side a number of times. Let's look, for example, if we multiply x by 10, this will be 5.5555, so on and so forth. Now, the most important thing to look at is the number in the tenths of the original number, value of x. If the number is the one that it's just one number that is recurring, then you just multiply the value of x by 10 to get this. And once you do that, pick the first, this is the first equation, pick the second equation, which is 10x, which is equals to 5.5555, and then subtract the first equation, which is x, 0.5555, from the first equation. Subtract this from the first equation. That means 5 minus 5 is 0, 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 5 minus 0 is 5, and then 10 minus 1x, remember this is 1x, 10x minus 1x becomes 9x. So we are interested in getting the value of x, which means we shall divide both sides by 9. Therefore, x is equals to 5 all over 9. So 0.5 as a fraction is 5 all over 9. Let's see if what we have done is correct. Let's convert 5 over 9 into a decimal. We said we use a very simple formula. Denominator out, numerator in. Denominator is 9, numerator is 5. Denominator out, numerator in. Therefore, 5 is not divisible by 9 because 5 is smaller than 9. So therefore, we say it is not possible. Then we add 0 to 5 to make it 50. 50 divided by 9, we know that 9 times 5 is 45. That is the nearest number that is divisible, that is a factor of 9 near 50. So 9 times 5 is 45. When you subtract, you get 5. 5 again is not divisible by 9, so you add a 0. Again 5 because of 45. When you subtract, you get 5. Add a 0. Again 5 because of 45. When you subtract, you get 5. Add a 0 here. Again 5 because of 45. That will continue like that endlessly. That's why we're calling them non-terminating decimals or recurring decimals. So 5 will continue recurring, and that is the case here. We can see we have been able to get the fraction of 0.5 where 5 is recurring. So let's look at other examples. Let's look at other examples of the same. Let's look at other examples of the same. Let's look at other examples of the same. We have 0.6. This is example 2. Convert 0.6 where 6 is recurring. Convert 0.6 where 6 is recurring. So this means our value of x, in this case, you can call it x, you can call it y, you can call it a, you can call it z. We want to get this. We assume this is the fraction that we want to get. We want to get x. So the original decimal is 0.6666 where 6 keeps recurring. So you're going to look for a multiple of 10 that we shall multiply by x to move this decimal towards the 10th side or towards the right. And still, when we subtract, we eliminate the decimal. So let's look at 10x. 10x will be 6. That is, we multiply this by 10. When we multiply this by 10, you get 6.6666, so on and so forth. This means then we are good to go because the number in the 10th place is the same in 10x is the same as the number in the 10th place in x. So learners, remember, the most important thing is to check the number in the 10th place. When I talk about tenths, I'm talking about tenths, not tenths. I'm talking about the 10th place. So this is our equation 1, and this is our equation 2. So I'll take equation 2, which is 10x, which is equals to 6.6666 recurring, and subtract equation 1, which is x is equals to 0.6666 recurring. So what I'm doing here, I'm subtracting. 6 minus 6 is 0. 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 6 minus 0 is 6. And 10x minus 1x becomes 9x. Becomes 9x. What you're interested with is being left with x on one side, so we shall divide both sides by 9. When we do that, x is equals to 6 all over 9. But we say always, rules of fractions. Rule number 1 of fractions is that fractions should always be in the simplest form. Fractions should always be in the simplest form, which means there's a great common divisor between 6 and 9. And the greatest common divisor, we can see here, it's 3. So when you divide 6 by 3, you get 2. And when you divide 9 by 3, you get 3. Therefore, this is 2 all over 3. So x is 2 all over 3. We have been able to convert 0.6, where 6 is recurring, to a fraction. And this is the fraction that this decimal came from. This is the fraction where this decimal came from. We have other examples whereby you can be given an example like this is example 3. You are given two numbers which are recurring. Like you are given a number like 0.71 where 7 and 1 are recurring. Where 7 and 1 are recurring. So as usual, the first step, write the recurring decimal. This is written as 0.71, 71, 71, 71, so on and so forth. This becomes our equation 1. This shows that 7, 1 is recurring, or 7 and 1 are recurring continuously like that. So let's multiply x by multiples of 10 and check and move this decimal towards the right to check where, when we subtract from this original number, we shall be able to get 0 on the decimals part. So we shall multiply our x by 10 first. When you multiply this number by 10, you'll get 7.171771. You see now, in the 10th place, we cannot be able to subtract 7 and 1 and get 0. So we'll try 100x. We multiply this original number by 100, which means we move this decimal to the right twice. So that means our answer will be 71.717171. So you see, now when you look at this one, after the decimal we have 71. On the original x, we have 71. That means when we subtract these, we'll not have anything left on the decimal part. So we are going to choose this as our equation 2. This one does not qualify to be our equation 2 because after the decimal we have 1. And when you subtract 1 from 7, you'll get, or 7 from 1, you'll not get 0. Therefore, let's pick our equation 2, which is 100x, which is equals to 71.717171. And then we get our equation 1, or the original equation, which is x is equals to 0.717171. Let's subtract the two equations. When you subtract the two equations, 1 minus 1 is 0, 7 minus 7 is 0, 1 minus 1 is 0, 7 minus 7 is 0, 1 minus 1 is 0, 7 minus 7 is 0, point. 71 minus 0 is 71, equals, this is 100 minus 1, which is 99x. Then divide both sides by 99, divide both sides by 99, so that 99 cancels to get x as 71 all over 99. So this is the fraction version of 0.71, where 71 is recurring. On our screen, we have some other examples. We have 0.8, 0.8. We have 0.45, where 4 and 5 are recurring. So if we have 0.45, where 4 and 5 are recurring, let's look at that. Let's do that. So 0.45, 4 and 5 are recurring. How do we go about this? First of all, let's call it a R. Let's our R, or the unknown fraction, or the unknown, let's make this a full decimal now, is 0.454545, because according to the notations here, it shows that 4 and 5 are recurring. 4 and 5, 4 and 5, 4 and 5, 4 and 5. So we want to move these, we want to have a multiple of 10 that we shall multiply by r to give us a number where the 10th digit will be the same. So when we multiply r by 10, what we call 10r, we shall move the decimal towards the right once, because we only have 1 0 here. So that becomes 4.54545. And you see now, our 10th digit is 5. And in the original, our 10th digit is 4. So we need to move until we reach where the recurring decimal is starting. So we shall multiply again this by 100, which means when we multiply by 100, we have 45.454545, so on and so forth. Now you see, R, learners, and 100R, the digit in the tenths, are the same. The digit in the hundreds, the digits in the hundreds are the same. Thousandths are the same. So when we subtract from this original one, we shall get 0 on the decimal part, making it easier for us to be able to get a fraction. So we shall pick equation 2 and subtract it from equation 1. So 100R is equals to 45.454545. And then this is recurring, subtracted from R, which is, or subtract R from 100R, which is 0.454545. This is recurring. And then when we subtract the two, 5 minus 5 is 0, 4 minus 4 is 0, 5 minus 5 is 0, 4 minus 4 is 0, 5 minus 5 is 0, 4 minus 4 is 0. Put your decimal there. 45 minus 0 is 45. And then 100R minus 1R is equals to 99R, which is equals to 45. We want to be left with R on one side, so we shall divide both sides by 99. 99 cancels, so we have r being equal to 45 all over 99. But again, we said fractions should always be in the simplest form. That means if you look at these two, both of them are divisible by 3. 45 is divisible by 3. 45 divided by 3 is 15. And 99 divided by 3 is 33. Again, 15 and 33 are divisible by 3. So 33 divided by 3 is 11, and 15 divided by 3 is 5. That means our fraction in the simplest form is 5 over 11. So r is equals to 5 over 11. R is equals to 5 over 11. Let's look at other examples. So you should be able to, let's first of all go through these. Let's go through these. The first step, get your r, which is now the full version of this recurring decimal. That becomes your original equation, or equation 1. Then multiply by a multiple of 10, starting with 10. When you multiply r by 10, you get 4.54545 recurring. But now you see, this is not enough for us because we want to subtract the decimal part and eliminate it. Ensure the answer we get on the decimal part is 0. So we are looking for a number when multiplied by r will give us a number where the tenth number is 4. So when we multiply r by 100, we realize that the recurring part of r repeats itself again. So subtracting becomes easier. That's why we settle for 100 r. For 100 r. That's why we settle for 100 r. If you look at the first case where we had 0.6 recurring, for example, this is the same as 0.6666. We settled for 10r or 10k or 10x. Reason being, when you multiply by 10, you move this decimal once. And then that means subtracting the decimal part to get a 0 becomes easier when you multiply by 10. So when the recurring, we can say that when the recurring numbers are 2, multiply by 100. When the recurring numbers are 3, multiply by 1,000. Let's have some other example on our screen. Let's have some other example on our screen. We have C, which is 0.315. So this is example 5, 0.315, where 3, 1, and 5 are both all recurring. That means our A, you can call it our A, is 0.315, 315, 315. What is recurring here is everything with annotation on top of it. Some other books will show you that we write like that without annotation on one. It still remains that the three numbers, the 3 digits are recurring. So you indicate like that. That becomes our original equation. Then if we multiply this by a multiple of 10, let's start by multiplying A by 10. So 10A will be 3.15, 315, 315. And then you see that the 10th digit is in the original number is 3. And in our number that we have multiplied by 10 is 1, which means if we subtract these, we don't get a 0. So we go and try 100A. 100A will be 31.5, 315, 315. And you see still, learners, that we have 5 here and we have 3 here. When we subtract, we will not get 0. Then we move to 1000A. We are multiplying by multiples of 10. Multiples of 10 are 10, 100, 1,000, 10,000, 100,000, 1 million, 10,000, so on and so forth. So 1,000R will move our decimal here 3 times to the right, which makes it 315.315 recurring. And if you look at this, then we have our recurring fraction coming here. That means on the original fraction and on our multiple of 1,000, we have When we subtract 3 and 3 will get 0, 1 and 1 will get 0, 5 and 5 will get 0. We have moved the decimal to the part where that is recurring, That means this qualifies to become our equation 2. So we shall have equation 2 minus equation 1. So 1000A will be equal to 315.315315 recurring. Our A was 0.315315 recurring. So when you subtract the two equations, you shall have 5 minus 5, which is 0, 1 minus 1 is 0, 3 minus 3 is 0, 5 minus 5 is 0, 1 minus 1 is 0, 3 minus 3 is 0. So the decimal part is eliminated, which becomes easier for us to get the fraction. So we subtract 315 minus 0, which we get, we subtract 0 from 315, sorry, we get 315. Equal sign remains. 1000A minus 1A becomes 999. 999A, we divide both sides by 999. Divide these by 999. So 999 cancels. We are left with A being equal to 315. 315. So A is equals to 315 all over 999. Now, let's check if this is in the simplest form. Of course, both of them are not divisible by 2. For a number to qualify to be divisible by 2, the last digit should either be 0, 2, 4, 6, or 8. 0, 2, 4, 6, or 8. Therefore, none of them is divisible by 2. Let's check divisibility test of 3. When you want to know if a number is divisible by 3, you add the digits. And if they form a number that is divisible by 3, then the entire number is divisible by 3. So 3 plus 1 is 4. 4 plus 5 is 9. 9 is a number divisible by 3. 9 plus 9 is 18. 18 plus 9 is 27. 27 is divisible by 3. So we shall divide 315 by 3. 315 divided by 3. 315 divided by 3. Divided by 3. This is 1 because of 3. 0, drop 1. Okay, it's not enough. So you put a 0 here. It allows you to drop 5. 15 divided by 3 is 5. So this is 105. 999 on the other side divided by 3 will be 3 because of 9. Remember 0, drop 9. Again, 3 will get into 9 3 times. When you subtract to get 0, drop 9, you'll get into 3 9 times. Or 3 will get into 9 3 times. So you're left with 0. So this is 333. Again, let's check. 1 plus 0 is 1. 1 plus 5 is 6. 3 plus 3 is 6. 6 plus 3 is 9. So both of them again form a number divisible by 3. That means 105 is divisible by 3. When you divide 105 by 3, you'll get 35. And when you divide 333 by 3, you get 111. And therefore, that becomes the end. That becomes the end of our fraction because they don't share anything in common. Therefore, our A will be 35 all over 111. 35 over 111. A key thing to note here, as I said, if the recurring digits are 3, like in this case we have 3, 1, and 5, which is recurring, then the tip is multiply by a multiple of 10 which has got 3 zeros, and the multiple of 10 which has got 3 zeros is 1,000. If there are 2 digits recurring, multiply by a multiple of 10 with 2 zeros. That is when we had an example of a number like 0.35, where 3 and 5 are recurring. Multiply these by a number that is equivalent to 100 to be able to eliminate this part which is recurring, so that when you subtract the rest, you get a 0 on the decimal spot. Let's go to some more examples. We have some other different examples whereby we have a whole number starting, like we have 5 point something. We had on our screen, we have 5.8, where 8 is recurring. Okay, 5.8 where 8 is recurring. We also have 1.85. So this is 1, 2, we have 1.85 where 8 and 5 are recurring. So let's start with 1, 5.8 where 8 is recurring. In this case, let's call it our x. Our x will be 5.8, and remember it's 8 which is recurring, so 8 will be recurring like that. That becomes our original equation, our equation 1. So, as I said, if the number recurring is 1, it is wise to multiply by a multiple of 10 with 1 0, which is 10. So when we multiply x by 10 learners, which is 10x, this becomes 58.8888 recurring. And of course, if we subtract this from this, we shall eliminate the decimal part. So we choose that to become our equation 2. If that becomes our equation 2, then equation 2 minus equation 1 will be 10x, which is 58.8888 recurring, minus x, which is 5.8888. When we subtract these, we shall get a 0 on the decimal side. 8 minus 8, 8 minus 8, 8 minus 8, all is 0. And then 8 minus 5 is 3. 5 minus 0 or minus nothing, you drop just 5. Then we have our equal sign. 10 minus 1 is 9x. Then we want to be left with x, so divide both sides by 9. That means our x will cancel out, so that we are left with x is 53 all over 9. Then another rule of fractions, you can never leave a fraction as an improper fraction. Always make it a mixed fraction. Make it a mixed fraction. So we shall pick our x, which is 53 all over 9. Learn us to convert these into a mixed fraction. We use a very simple formula that I've been using all along, which is denominator out, numerator in. Denominator is 9 out, it's out. The numerator is in, which is 53. So we ask ourselves, how many times will 9 get into 53? How many times will 9 get into 53? So 9 will get into 53 6 times, because 5 times. 5 times because of 45. When we subtract, we shall have 13. 13 minus 5 is 8. We borrow 1. We borrow 1 from here, so that this is 4 left. And then we have add 1 there. That becomes 13. 13 minus 5 is 8. Now, if we have 5 as the whole number and our remainder as 8, then our fraction is 5, 8 over 9. So our x is 5, 8 all over 9. This is the fraction which was converted to give out 5.888 recurring as a decimal. I'll look at 2. 2 is 1.85. 1.85. 1.85, where 85 is recurring. Where 85 is recurring. Where 85 is recurring. So the first thing, we'll have our R as 1.85858585, like that. That means 8 and 5 are recurring. As I have said, if the numbers recurring are 2, the digits recurring are 2, it is wise for you to multiply by a multiple of 10 with 2 zeros, which is 100. So let's just multiply these directly by 100. When we multiply by 100, we shall have 185.858585. At grade 8, this should not be a problem because you have calculators and you're allowed to use them. So you should be able to move fast. You should be able to move faster than grade 6 and 5 and lower classes. When we have these, that means this qualifies to be our equation 2. Reason being, when we subtract 85 from 85 here, we shall get 0. 85 from 85 here, we shall get 0. And this was our equation 1. So let's subtract equation 2 from equation 1. 100R is 185.858585. Subtract R from there, which is 1.858585. Subtract these two, you get, on the decimal part, you'll get 0 point, because everything here will subtract to get, you get a 0. 5 minus 1 is 4, then you drop 1 and 8. And then 100 minus 1 is 99R. Divide both sides by 100. Both sides by 100. By 99. 99 will cancel out, so you are left with R being equal to 184 all over 99. And this is not yet in the good form we want it to be. So we must make that a mixed fraction. We must make that a mixed fraction. We have said we use a simple formula. Denominator in, out, numerator in. Denominator out, which is 99. So we have R is equals to 99 all over, is equals to 184 all over 99. So denominator is 99, denominator out, numerator in, 184. How many 99s will get in 184? Definitely it's going to be 1, because 99 times 2 is 190 something. So 1, because of 99. When we subtract these, we borrow 1 here, we are left with 7. This becomes 14. 14 minus 9 is 5. And then we have 17. 17 minus 9. 17 minus 9 is 8. So our fraction will be 185 all over 99. Therefore, our R is one whole number, 85 all over 99 as a fraction. I still want to get some more examples from the screen whereby we have one of these digits which is recurring and the other one is not. I will look at the last example, which is 3.72, where 7 is recurring. Sorry, where 2 is recurring. 3.72. 3.72, where 2 is the one that is recurring. So our let's call it our y. Our y will be 3.72222, where 2 will keep recurring. This is our original equation. So you see, learners, we have to ensure that I think I saw, I kindly project the questions again. That was 3.72 and okay, so what is recurring is 7 and 2 in this case, is 7 and 2. So that means that our fraction here is 727272. We have done this example previously where I've said that if the two digits recurring are 7 and 2, that means you multiply just by a multiple of 10 with 2 zeros. That means if you multiply this by 10, that is 10y, this becomes 37.27272. And you see, we cannot be able to subtract 7 and 2 to get 0. So let's move on to 100y, which is 37.3, when you multiply y by 100, that means you shall move these to 372.727272. So that qualifies to be our equation 2. because when you subtract 72 from 72, we'll get 0, 72 from 72 will get 0, and 72 from 72 will get 0, eliminating the decimal part. That means our equation 2, which is 100y, 372.727272 recurring, minus our original equation, which is 3.727272 recurring. If we subtract the 2, we shall be able to get 99y is equals to, the decimal part will go, we'll be left with 0. We'll borrow 1 from here, so this is 6 and this is 12. 12 minus 3 is 9. 36 is left. 36 is left. So y divide both sides by 99. So you're left with y is equals to 369 divided by 99. First of all, before making this a mixed fraction, you have to ensure it is in the simplest form. You have to ensure it is in the simplest form. And what shall we do? We shall check for divisibility test of 3, because both of them are not divisible by 2. Remember, we use the prime numbers 2, 3, 5, 7 to check for divisibility test. So these, you add the digits. 3 plus 6 is 9. 9 plus 9 is 18. 18 is a number divisible by 3. 9 plus 9 is 18. 18 is a number divisible by 3. So divide these by 3, you'll get 33. Divide these by 3, you'll get 139. Again check 129, sorry. 123. 123. Again check if this is divisible by 3. Add 1 plus 2 is 3. 3 plus 3 is 6. Again, both of them are divisible by 3. Divide this by 3, you get 11. Divide this by 3, you get 41. So these are not divisible by any, by 3, by 5, or by 7. So y will be 41 divided by 11. Then use my simple formula of converting these into a mixed fraction. Denominator out, numerator in. Okay, 11 multiplied by 3 is 33, which is the largest multiple of 11 that is closer to 41. 41 minus 33 is 8. 8. So our fraction is 3 whole number, remainder 8 over 11. Therefore, our y is 3, 8 all over 11. So learners, you have to be very cautious. You have to also ensure that you leave your answer in the simplest form. Do not proceed to make this a mixed fraction before you simplify it first. So simplify first and then make it a mixed fraction. I would want, there's an exercise for you learners on the screen. The last slide, which is an exercise assignment. In your assignment, you are told to convert 2.53 where 3 is recurring. I'll do that first question for you. That is, we have not looked at that kind of an example. I'll do that for you as we wind up our lesson. 2.53, 2.53. And in this case, the recurring number is 3. So let's make it, let's call it k. Our k, let our k be 2.5333. This is our first equation. When we multiply this by 10, which is 10k, this will be 25.3333. Okay, we can call this our equation 2. But now, when we subtract equation 1 from 2, you will not get 0 because we have 5 here after the decimal and 3 here. So let's move to another one and multiply by 100, sorry, which makes it 253.3333. that being our equation 3, look at our equation 2 and equation 3. After the decimal, all the digits are the same. So it's easier to subtract equation 2 from equation 3 than it is to subtract 2 from 1 or 3 or 1 from 3. So we shall pick equation 3, which is 100k, which is 253.3333, and subtract equation 2, which is 10k, which is 25.3333. Subtract these two. When you subtract these two, we shall get that these will be 0 point. Then we shall borrow 1 here. This will be 4. This will be 13. This will be 8. So 13 minus 5 is 8. 4 minus 2 is 2. And then we drop 2. 100 minus 10 is 90k. Divide both sides by 90. Divide both sides by 90. 90 will cancel, so that our k is 228 divided by 90. Still, learners, we have to leave our fraction in the simplest form. We have to leave our fraction in the simplest form, which means both two, if you look keenly, you'll see that 228 and 90 are both divisible by 2 by checking divisibility test of 2. The last digit is either 0 or an even number, which means 8 is an even number and 0 is here. So divide this by 2, you get 45. Divide this by 2, you get 114. Now you see that they are not divisible by 2. Let's check divisibility test of 3. If you check divisibility test of 3, you add the digits. 1 plus 1 is 2. 2 plus 4 is 6. 6 is divisible by 3. 4 plus 5 is 9. It's divisible by 3. Divide this by 3, you get 15. Divide this by 3, you get 3 because of 9. Remainder 24, 8. Then if you add 3 and 8, you get 11. 1 and 5, you get 6. So they are not divisible by 3. Therefore, our k is 38 all over 15. Then let's make these a mixed fraction. It is denominator out, which is 15, all over numerator in, which is 38. How many times will 15 get into 38? 15 will get into 38 2 times because of 30, and we shall have a balance, a deficit of 8. Therefore, it's 2 whole number, 8 all over 15. That's how we go about when we have only one of the digits in the tens place and above recurring. That is how we go about it. We don't have necessarily to subtract from the original decimal. Therefore, learners, that was our lesson. I hope you've learned. We have an exercise on the screen. I would ask that you try to look at those questions on your screen. Please check those questions on your screen. On question 4, you realize that the recurring decimal numbers is only 5 that is recurring. So that means you shall multiply by 100 to move up to 417.5 and have that part which is recurring so that you're able to subtract from it. I hope you gauge yourself with those examples on the exercise on the board as an extra work. Thank you very much for this class. I was your presenter, Arthur Kithinji, again from ACK St. Michael. I want to say thank you very much to Elimu TV for this chance to communicate to my learners. Those who are watching me on YouTube and other platforms, thank you so much. I want to say hi to my learners, to their parents at home. Welcome back to school. It's a new term. Let's keep this going. Thank you. All the best. Have a good day.